This is a quick video to resolve an issue that many of us saw in class the other day about the trend line and the data not matching up as we expected. So the problem we were considering was on page 158 of the notes, and you were given quantity and profit information. So in this problem, if you're selling 30 items, you're losing $68, and if you sell 179 of these objects, whatever they may be, you're making a profit of $319, let's say. And the point of this problem was to take this data and fit it with a profit function in Excel, and then use that profit function to create a predicted profit row and to create a marginal profit row in Excel, and then to observe the relationship between the marginal profit and also to add a derivative of the profit row and to see how those matched up with where the maximum profit occurred. So many of us the other day had put these values into Excel to obtain something like this. This is a student solution that somebody was kind enough to send me. And here we can see their items, the profit, and they plotted the profit function and fit the data with a trend line. So they've added a trend line, and in this problem they are using a polynomial degree 3 because that seems to fit the data pretty well. So we can see here's our trend line, and the equation is right here. And so the student did what seems to make sense. They put this formula into Excel to create a predicted profit column, and I think we can see that right here. They put this formula, negative 0.005 x is the quantity or the number of items cubed, and they input this formula correctly, and they drag this across the cells to get these numbers. Now we're starting to see something very unfortunate happening, as for example at 140 the number of items, the profit is 420, but the predicted profit is 288. So at this point of 140, the numbers do not match up with what is showing on the plot. The trend line should be very, very close to the actual profit at this point. But the numbers from our formula are showing 288, which is down here. So if this number is correct, this dotted line should be going through about 288 over here, but it is not. So we have an issue. This predicted profit column is off, and that's going to throw off our predicted marginal profit. So the resolution to this problem is that this function that we are being shown here is not the actual function that is being used by Excel to create this blue dotted trend line. What we need to do is we need to format the trend line label. What is happening here is that the formula is not showing us enough decimal places, and there is some rounding error that is happening, or when we are typing in this formula and we are not getting the right numbers because of round off error or some missing decimal places. So we need to format the trend line label, change this to a number, and then we can bump this up the number of decimal places to say, let's say 6 decimal places. And now you can see here that the formula that we are using, the formula that Excel is actually using, is a little bit different than what we have actually typed. Instead of minus 0.005, what is actually being used by the computer is 0.00451. So we need to update this formula to more accurately reflect what Excel is actually using. And I will just switch these numbers, 0.1109 83, and I would suggest maybe 5 to 6 decimal places. Minus 3.16666869. So these little errors can actually have big effects, as we are seeing. We have not seen these errors before because we have never really needed to use higher degree polynomials. Quadratics, everything seems to be fine with what the computer is giving us as its standard answer. But when you go to higher terms, these small errors can have more of an effect because of the cube terms or the fourth degree or fifth degree terms. So if we update this formula and drag this across now, we should see these numbers change dramatically. And let's see, the predicted profit. We can see that these at 66 right here, they are quite a bit separated, which is showing 21 and 73. So that's not unexpected. And here at 140, this is our test. At 140, your new formula. At 140 right here, these should match very well. And we see that they do, 420 and 423. So now I'm feeling more confident in our answer. So if we drag these across here, oh, it looks like those have updated. Okay. And then what we need to do is update the derivative, the predicted marginal profit, and maybe what we should say here is instead is using the predicted marginal profit approximation, which is the derivative of the profit. Okay. So let's create this column, and that will necessitate that we open up Maple to take the derivative of this function. This student had also sent me their Maple file. Okay. And they put in their function. Okay, here was the function that they were trying to put in originally for their profit function, f of x. Let me change this instead of f. Let me call this profit as a function of q. And let's update this formula to be 0.00451. Q cubed. I prefer to use the actual letters that we're using in the problem, the variables. Q for quantity. I'm just updating this. It'll take not too long. 869 Q, and we should get this formula for the profit. 657, if I'm typing this correctly. 253657. Okay. We've seen that. So here's your profit function, and let's just put prof prime of q. And here is now your derivative, much more accurately, that we should be able to put into Excel. Sorry, let me minimize some windows so we can see everything that we need to see. Okay, so if we want to put in this function, it should be minus 0.001353 times the number of items squared plus 0.221966 times the quantity to the first minus 3.166869. And here's our predicted marginal profit. And it's this, right, our predicted marginal profit approximation, because we want to, and by using the derivative of the profit function. And it's here that we're going to get, this is our, it's an approximation to the marginal profit, but it's going to be a much closer answer and a much much more accurate way to find where the maximum profit occurs. So what we are looking at here is we can now goal seek on this. You can see that our marginal profit approximation, if we sell one more than 30 items, we're going to make about $2.27 more. If you sell one more item than 140 of them, you will only make $1.38, which is a decrease from $2.27. So we can see that as we're getting closer to this 140 mark, our our profit that we get by selling one more item is getting smaller. So this is saying that as you start to get closer to 140 items, I would slow down the buying or the trying to make more items to sell, because it's going to cost you more than it is that you're going to bring money in by selling them. So that's what the profit is telling us here. So if we want to figure out when we have found that the maximum profit is going to occur where the marginal profit gets close to zero. So somewhere in here, it went from positive 238 to minus 91. Zero is somewhere in the middle there. And I think we can see here that we're getting a much better answer here. 5.9, 1.3, somewhere around in this area. The derivative is going to be telling us where we have the maximum profit. So if we goal seek, let me see how do I do this. Data, it's a little different on the Mac. What if analysis, goal seek, same process though. Set this value to 0 by changing the number of items. Okay. And we can see here that around 148 items here, that's where our maximum should occur. Okay. So the max profit would occur somewhere around selling 148 items. So the whole point of this video was just to resolve this issue with the number of decimal places in the formula that Excel is showing us, and we need to ask it by formatting the trendline label. If you format the trendline label, change it to number, and you can change the number of decimal places that you're seeing for what the computer is actually using for this plot. So that should resolve this problem, and we will continue to work on more of these maximum profit problems in the future.